I'm going to go over the homework solutions for section 4, the addition law of probability. Starting with number 2. Number 2 says a bag contains 12 red, 3 blue, 6 green, and 4 yellow marbles. If a marble is drawn from a bag at random, what is the probability of the marble will be either blue or yellow? So on this one, I'm going to go back and handle it the basic probability way, where you just have one fraction, and so the probability, of blue or yellow, and probability is a fraction with a denominator being the total number possible. So we have 12 red, 3 blue, 6 green, 4 yellow. Add those up, and we're going to get what? 25. And then how many blue or yellow do I have? So I add the blue and the yellow together, and I get 7. So 7 out of 25. If I multiply top and bottom of that fraction by 4, I get 100 as the denominator. I get 28 as the numerator, and that's 28%. Percent just means a fraction over 100, and so we can see that the answer to number 2 is B. Alright, let's skip now to number 4. A bowl contains red, green, blue, and brown candies. Joey took a handful of only green, brown, and red. Now Danny will randomly take out one candy from the bowl. Which of the following is not true because of Joey's action? And there's some possibilities here. So on this one, we just have to slowly go through it case by case and see what the deal is. Okay. So the first one says the probability that Danny's candy will be blue may have decreased. Okay, so we have, well, let's say we had 4 of each. Okay, say we had 4 red, 4 green, 4 blue, and 4 brown. Just to create an example of what could be there. And if you took a handful of just the green, the brown, and the red, so that means the green, the brown, and the red would go down, but the blue would stay the same, right? So let's say, for example, they took one of each of those. So if they took one, say they grabbed one green, one brown, one red, what would happen? Well, before, the probability of Danny getting a blue, so let's look at before this happens, would be 4 out of 16. But after this happens, there's still 4, but then the denominator goes down because you're taking away some of the green, some of the brown, some of the red. So in this case I said 1 of each and you go to 13, but they could have taken more, and the denominator would have gone down more even so. So if the numerator stays the same but the denominator decreases, what happens to the overall fraction? And you should know that the overall fraction, the value, gets bigger. So if you try 4 over 16, that's going to be like 0.25. If you try 4 over 13, you're going to get something bigger than 0.25, and you can try that out. So number 1 is a false statement. Number 2 says the probability that Danny's candy will be green may have unchanged, or may have not changed. Okay, so let's take a look here. Before anything happened, in our case, we have 4 green out of 16, and then after, let's see here, what could happen. let's say, is it possible that we can get it unchanged? Well, if we take, well, we can get a fraction of 3 out of 12. Here's how. If we took one green, okay, so then there would be 3 greens left, and then there were 16, so let's take 2 brown instead of 1, and let's take 1 red candy. So we take 1 green, 2 brown, 1 red, and so now it's only out of 12 left over, and so we get a probability 3 out of 12. So 4 out of 16 reduces to 1/4. 3 out of 12 reduces to 1 out of 4. And so the probability that Danny's candy will be green may not have changed. That could be true. So we're just kind of playing around with the numbers, seeing what's possible, or seeing if we could disprove the statement, like in number 1. The third statement, the probability that Danny's candy will be brown may have increased. Alright, so brown, before anything's happened, in our case we had 4 brown out of 16. This is just an example here. And now let's see if there's a way that we can select green, brown, and red, and the probability of brown go up. Well, I think we can get the fraction 3 out of 9, which would make it go up. So this is 1/4. This would be 1/3, which is greater. And here's how we can do this. So I'm going to scratch these again. Let's say we're only going to take 1 brown. And let's take 3 green and 3 red. So altogether we're taking 7, so I'd reduce it from 16 to 9, and there'll be 3 brown left over. And so if this is a case that would follow what could happen and increase the probability of selecting a brown. So this could also be true. So you just got to go case by case. Which of the following is not true? So the only one that said was false was A, so you got to go with A. Not a quick problem. Alright. Number 5. The following people are in a room: 5 men over 21, 4 men under 21, 6 women over 21, and 3 women under 21. And 1 person is chosen at random. The following events are defined. I'm just going to say, let's assume nobody's 21, because that case is not even considered here. But let's just assume that nobody is 21 here. Okay. Alright, so let's organize this information. We have, you can either be under 21 or over 21. And you could either be a male or female. Alright, we have 5 men over 21 and 4 men under 21, 6 women over 21 and 3 women under. Let's total this up. We get 9 men, 9 women, 18 total people, 11 are over 21 and 7 are under 21. Also, event A is that the person is over 21, so A goes here. B is the person under. C is the person is male, and D, person is female. So for A, we want the probability of B or D. Notice that B or D, B and D can happen at the same time. We got 3 people that are both female and under 21. And so the formula would be the probability of B plus the probability of D minus the probability of B and D. So using our table, probability of B, well, there's 7 people total under 21 out of 18. So 7 out of 18. Probability of D, there are 9 total females out of 18 people, minus B and D, there are 3 people that are both female and under 21, so it's 3 over 18. So 7 plus 9 is 16. 16 minus 3 is 13 out of 18 for our answer for A. Okay. For B, we want the probability it's not A or not B. Okay. A is over 21. So keep in mind that the probability of not A is actually the probability of B, because we're assuming nobody is 21. So B would be the opposite of A. Also, the probability, sorry about that, also the probability of not B would be the probability of A. So what's stated here, the probability of not A or not B, is the same thing as saying what's the probability of B or A. Now, those are what we call mutually exclusive events. They can't happen at the same time. Either you're under 21 or you're over 21, but you can't be both. And so this formula is going to be the probability of B plus the probability of A. You could put minus the probability of A and B, but that probability of A and B is going to be 0, because it's impossible to be both under 21 and over 21 at the same time. So you don't need that part. Probability of B is 7. There's 7 under 21 out of 18. Probability of A is 11. There's 11 over 21 out of the 18. And so we end up with 18 out of 18, which is 1. Meaning it's going to happen. It's either going to be under 21 or over 21 if you pick one person out of this 18. Alright, 6 you guys did, or we did together in the notes. 7, let's do that one. In a single throw of 2 dice, what's the probability that neither a double nor a sum of 9 will appear? Alright, I'm going to create a table to help us out with this one. So the table itself helps us list out all the sample space, or all the possibilities we can look at. We're talking about sums or doubles. I'm going to put in my table, I'll put sums. Alright, now some of these sums come from doubles, and actually the doubles, if I get this 2, I rolled a 1, 1, or if I roll a 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. So those come from doubles. So I don't want a double, right? It was a probability that neither a double nor a sum of 9. So I don't want a sum of 9 either. I'm going to highlight my sums of 9. So what I'm highlighting is what I don't want, but I want everything else. So a couple ways to do this. We can do elementary probability, where we just count up everything that's not highlighted and put it over 36. You can think of the complement, the backdoor approach, and let's count up everything that is highlighted and subtract that from 36 to find out what's remaining. So I'm going to write out what we want here. So probability of A, where A is that it's not a double, nor a sum of 9. So not a sum of 9. So A is not a double, B is not a sum of 9. But when I say nor, I'm not saying or. I'm saying I don't want one and I don't want the other. If you read this carefully and get the meaning out of it, it's neither a double nor is it a sum of 9. So this is saying, hey, I want A, which is not a double, and, not or, and I don't want a sum of 9. It's tricky language here. It's not an OR problem, so you don't want to use one of those OR formulas. Let's go back to elementary probability here, and so that we know it's out of 36. If you count what's highlighted, you end up with 10, so subtract 10 from the 36, you get 26, reduce, and you got your probability. Number 9, find the probability of B. You have the probability of A is 0.5, the probability of A and B is 0.3, and the probability of A or B is 0.6. So formula, you got to remember, probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And just plug in what we know and solve for what we don't. So 0.6 is equal to 0.5 plus x, I'm solving for that, minus 0.3. Careful, it's an x, it's not a times symbol. I'll just make it look a little different, okay? So 0.5 minus 0.3 is 0.2. So 0.6 equals 0.2 plus x, and subtract 0.2 and you end up with x is 0.4, or what we're after, the probability of B is 0.4. Number 10, what's the probability of A or B? The probability of A is 32%, probability of B is 17%, and A and B are mutually exclusive events. Mutually exclusive means that the probability of A and B is equal to 0, meaning they can't happen at the same time. So the formula is this, it's probability of A plus the probability of B. And that's the probability of A or B when we have mutually exclusive. So A is 0.32, I just changed the percent to a decimal. B is 0.17, and we end up with 0.49. Or you could say 49%, that's fine. On 11, we're given probability of A, the probability of B, the probability of A and B, and we want the probability of A or B, same formula. We know that A and B can happen at the same time because it tells us that there's a 7% chance that it can. Plug in what we need here, so 0.6 plus 0.2 minus 0.07. Careful because the 0.07 has 2 digits after. It might be helpful to think of these as 2 digits as well, so you got like 60 plus 20 minus 7. That would be 80 minus 7 is 73. So 0.73 is an answer for number 11. Alright, number 12. Spinner has 8 equal sections, numbered 1 to 8. What's the probability of the spinner stopping on a multiple of 3 or a number greater than 5? So here's my spinner. Oh, sorry, it's not 2. That would be... sorry. Let me fix that. Let me split into 8 sections first. And so probability it stops on a multiple of 3. That's going to be my event A. Greater than 5 will be event B for me. And so what's the probability of A here? First of all, probability of A, multiple of 3. Well, multiples of 3 would be 3 or 6. So there's 2 out of 8. Now I'm not going to reduce it yet. Probability of B for me here, something greater than 5. So it could be a 6, a 7, or an 8. So it would be 3 out of 8. What about probability of A and B? Could that happen? Or is that 0? If it's 0, then we know that the two events are mutually exclusive, but if it's not 0, then it can happen, right? So A and B, I mean, it's a multiple of 3 and it's greater than 5. Well, that would be the 6. And there's only one number out of the 8. So now we use our formula. So probability of A or B is the probability of A plus the probability of B minus the probability of A and B, which is 2 out of 8 plus 3 out of 8 minus 1 out of 8. So it's 4 out of 8, or 1/2. So I use the formula here. You could also use elementary probability where you're just counting the ones that apply out of 8. You should get 4 out of 8. But again, it's good to practice this formula until you have it memorized and see how it works. Number 13. Local aquarium has 6 turtles, 12 penguins, 8 sharks. If you randomly select one animal to watch, what's the probability it's a turtle or a shark? So turtle is A, shark B, so probability of A. We have 6 turtles out of, you got to count how many things we got here, 26, because you got 12 penguins, 8 sharks, and 6 turtles. Probability of B here would be, we have 8 sharks out of 26, and the probability of A and B, that would be, hey, if I'm picking one animal, what's the probability it's both a turtle and a shark? Not going to happen. So 0, which means these are mutually exclusive. So the probability of A or B is just going to be the probability of A plus the probability of B. You don't need to subtract the probability of A and B. You can, just subtracting 0, but you don't need to. So we got 6 out of 26 plus 8 out of 26, which is 14 out of 26. Reduce that, you get 7 out of 13. Alright. Next one. I think my numbering's off here, but hopefully yours isn't. Okay, so use the table to find the following probabilities. Before I do, I'm going to add up the marginal distributions here, the row totals and the column totals. So D adds up to 4, everything in E adds up to 11, everything in F adds up to 11. The grand total 11 plus 11 plus 4 is 26. Column C adds up to 6. B adds up to 10, and column A adds up to 10. Alright, so the probability of A would be, well, I have 10 total in A out of the grand total of 26. And we reduce that 5 out of 13. F, we have 11 total in row F out of the grand total of 26. Can't reduce that. A and B, so it needs to belong to both A and B. Nothing belongs to A and B. And so that's 0 out of 26, which is just 0. C and F, there's 1 that belongs to both C and F out of the 26. A or B, A, so A or B, that's probability of A plus the probability of B. And remember, A and B is 0 right back here, meaning they're mutually exclusive, can't happen at the same time. So we don't need that last part. So this is going to be 10 out of 26 plus another 10 out of 26. So 20 out of 26, which is 10 out of 13. Probability of C or F. Alright, so that's the probability of C plus the probability of F minus the probability of C and F, because C and F can happen at the same time. We saw that here in D. There's a 1 out of 26 chance. So probability of C is 6 out of 26. F would be 11 out of 26 minus 1 out of 26. So it's going to be 16 out of 26, which reduces to 8 out of 13. A given F. Now here's where it changes. We got this line here, this slash, which says, hey, your denominator is changing. It's no longer out of 26. It's out of everything in F. So you look at row F and notice the denominator is 11. I'm going to highlight this one. So we're just looking at these numbers, nothing else. So out of those 11, how many belong to A? 7 of them do, so 7 out of 11, that's your answer. For E, the denominator is going to be what? It comes from A, the A total is 10, so just look at column A, how many of those belong to F? 7. And for F, out of everything in column C, out of just those numbers, I'm going to circle them right now, out of just those, how many of those belong to B? None of them do, so we get 0 as a probability. Alright, and that should be it for this homework.